Hello again. Today we're going to keep talking about acids and bases, and we're going to learn how to calculate pH today and talk about what pH is. So first of all, when you have a sample of water, you always will have some of the molecules breaking apart to form a small amount of H plus and OH minus ions. Okay, so the water molecule, some of them will break apart and form H plus and OH minus. This is called the self-ionization of water. So in your glass of water, you're going to have some little H plus ions formed. They actually hop on another water molecule. So they make H3O plus and OH minus ions. So mostly the water molecules stay together, but you always get a small amount of these ions. So again, it's called the self-ionization of water. And so we're going to look then at how we can use the amounts of those to calculate. When we know the concentration of one of the ions, we can calculate the concentration of the other. Okay, so this H3O plus is called the hydronium ion, and it's exactly the same thing as H plus. It's just putting on a water, because H plus can't just be by itself. It will jump on a water molecule. Okay, and the double arrow indicates that the reaction goes in both directions. So as some water molecules break apart, then those two ions can get back together to reform water. So it can go both ways. And at equilibrium, when it's going this way just as fast as this way, those concentrations will stay constant. Well, pure water has an H3O plus or H plus concentration of 1 times 10 to the minus 7th, and then the OH minus is also 1 times 10 to the minus 7th, because the water is breaking apart. And I'm showing two water molecules because, again, the H plus jumps on the one. So one water molecule is splitting apart, but the hydrogen ion from that is jumping on another water. So that's why we have two waters on this side to make this. Again, this is it. This is the H3O plus, a water molecule with that H plus from the one water molecule on it. Okay, so we get an equal amount of H3O plus and OH minus in pure water. So this is called the equilibrium expression. Capital K is the equilibrium expression. Capital K for water is that those two concentrations multiplied together will equal 1 times 10 to the minus 14th at 25 degrees. So all of the equations we're going to do, we're going to assume they're at 25 degrees because that's just kind of a standard temperature for doing equations at. And so this becomes an equation to relate the H3O plus to the OH minus. Again, in pure water, they're both 1 times 10 to the minus 7th. So multiplied together, they equal 1 times 10 to the minus 14th. So what that means for us is that when we have the concentration of one of them, we can then get the concentration of the other one by dividing it into 1 times 10 to the minus 14th. Okay, so if it's pure water, they're both 1 times 10 to the minus 7th. But if it's acidic solution, there'll be more H3O plus and less OH minus. If it's a basic solution, there'll be more OH minus and less H3O plus. So we have to know one of these amounts, one of these concentrations, so that we can calculate the other one. So to calculate pH, we will be using the H3O plus concentration, and the equation for that is a logarithmic scale. pH is minus the log of the H plus or H3O plus concentration. Okay, so someone decided that it would be easier to explain how acidic or basic something is as kind of like whole numbers. So the pH scale pretty much goes between 0 and 14. But because the H3O plus and OH minus concentrations are so small, they made it a logarithmic scale. So if you remember log, like base 10 log, it's the exponent of 10. And someone also, whoever came up with this scale, decided that they wanted those numbers to be positive. So they put a negative sign in the equation so that when you take minus the log of the H plus or H3O plus concentration, you will most of the time get a positive number. So we will look at some examples of that. Okay, and once again, H3O plus and H plus are the same thing. Okay, so for example, in pure water, the H3O plus concentration is 1 times 10 to the minus 7. So if we take minus the log of 1 times 10 to the minus 7th, then we get a pH of 7. And that is what pure water has a pH of, 7. And the OH minus concentration would also be 1 times 10 to the minus 7th in pure water. So if the H3O plus concentration is 1 times 10 to the minus 7th, as I just said, then the pH is 7. Well, if the H3O plus concentration is 1 times 10 to the minus 6, then the pH is 6. So notice that 1 times 10 to the minus 6 is 10 times bigger than 1 times 10 to the minus 7th, but the pH goes down by 1 unit. So a difference of 10 times in the H3O plus concentration makes a difference of 1 for the pH. And the pH gets lower as it gets more acidic or more H3O plus. So when it's 1 times 10 to the, you can just look at the exponent and make it positive. So the same thing if the H3O plus was 1 times 10 to the minus 5, then the pH would be 5. If the H3O plus is 1 times 10 to the minus 3rd, then the pH would be 3. Okay, so it's easy to do when it's 1 times 10 to it. Okay, so the more H3O plus there is, the lower the pH will be, because again, we're dealing with negative exponents, and 10 to the negative 6 is a larger number than 10 to the negative 7th. But what about when it's not 1 times? Well, then you can't just easily look at it like those and figure out what the pH is. You need to plug it in your calculator. So what is the pH if the H3O plus is 3.8 times 10 to the minus 5th? Well, we know it'll be close to 5, okay, but it's not going to be exactly, because in your calculator it would be doing the log of the 3.8 minus the log of it, and then minus the log of the 10 to the negative 5th. So when we calculate that, minus the log of 3.8 times 10 to the minus 5th, it comes out to be positive 4.4. Okay, so this number being minus the log of lowered it from 5 a little bit. So you can just plug that in your calculator. Okay, so minus the log of 3.8 times 10 to the minus 5th, we get a pH of 4.4. So the more acidic something is, the lower the pH. Acids have a pH range of normally 0 to 6.9. When something's neutral, it's exactly 7. And when it is basic, it's bigger than 7 and up to 14. We will see later that actually acids, if it's a concentrated strong acid, the pH can actually be less than 0. It can be -1. But most of the time, our acids will be between 0 and 6.9. So bases produce more OH minus than is in water. So their pH will be higher than 7. Acids produce more H plus or H3O plus than water. So the pH for acids will be less than 7. So what is the H3O plus when the OH minus is 2.1 times 10 to the minus 9th? Okay, so from our first equation, 1 times 10 to the minus 14th divided by the OH minus will give us the H3O plus. So when we divide that, we get an H3O plus concentration of 4.76 times 10 to the minus 6. Make sure, again, when you're plugging in these numbers with the times 10 to the, you either have to put those in parentheses when you plug them in your calculator, or you can use the EE key. Make sure that you're getting 4.7 times 10 to the minus 6 when you divide those. Okay, so that would be the hydronium ion concentration when we were given the hydroxide concentration. So then what is the pH? The pH would be then minus the log of the hydronium ion concentration minus the log of 4.7 times 10 to the minus 6 is 5.32. So then we know that that is an acid. Make sure when you're calculating pH that you're putting in the hydronium ion, the H3O plus concentration or the H plus concentration, not the OH minus. Okay, so if we're given the OH minus first, you have to find the H3O plus and then take minus the log of that to get the pH. So that would be an acidic solution because it's lower than pH 7. If you want to go backwards from pH to H3O plus, then you need the inverse of log. So on your calculator, that's the 10 to the x key. If you look on your calculator where log is, the second function or the inverse function is 10 to the x. So that's 10 to the negative pH to go backwards from the pH equation to solve for the H3O plus when you have the pH. So 10 to the negative pH equals the H3O plus. So what is the H3O plus when the pH is 4.2? It would be 10 to the negative 4.2 that you're plugging in your calculator. So you could actually use the 10 caret key. You could do 10 caret negative 4.2, or you can do inverse log or the 10 to the x key negative 4.2. And you should get 6.3 times 10 to the minus fifth. Okay. If the pH is a whole number, like what is the H3O plus concentration when the pH is 4, that would just be 10 to the negative fourth. Or what is the H3O plus when the pH is 7? 10 to the negative 7. Okay, so when it's a whole number, when pH is a whole number, the H3O plus concentration is just 10 to the negative of that number. But when it has a decimal like this, you need to plug in your calculator so that you get an actual number like this. You can't leave it as 10 to the negative 4.2. Okay, so that's going backwards from pH to H3O plus. pOH is not something that we talk about too much because in our world we use pH to describe the acidity of things. pOH is kind of like the opposite. It's minus the log of the OH concentration. And so we're just definitely more familiar with pH. On commercials, they'll talk about the pH of different things, sometimes as a selling point. Supposedly, women's sweat perspiration is more acidic than men's or boys. So sometimes they'll talk about that the deodorant, this particular deodorant, is pH balanced. Or with shampoo, also sometimes if you had got a perm, for instance, you want to use more acidic shampoo. Otherwise, normally you want neutral shampoos, so they'll say it's pH balanced, things like that. So sometimes they use pH in advertising. But in general, we don't talk about pOH too much, but we can calculate it the same way that we calculate pH because it just means that the P means minus the log of. So pOH is minus the log of the OH minus concentration. So if the question was, what is the pOH if the OH minus equals 2.5 times 10 to the minus 6, then we would just plug in minus the log of 2.5 times 10 to the negative 6, and that would be 5.6. So that would be the pOH, not the pH. Well, the thing about the pOH is that pH plus pOH equals 14. So when we know the pOH, we could then subtract that from 14 to get the pH, and then that will tell us whether it's an acid or base because we have our pH scale. So we mostly use pOH to get to pH. And in the same way, if you were only given pOH, you can take 10 to the negative pOH to get the OH minus concentration. So these equations you can get from one thing to the other in different ways, but you do need to know these equations. So your assignment is going to be using those. There's 6 equations, and you're going to be given one of the components, and then you have to use different equations to find the other missing things. So these are the 4 things you're looking for: H3O plus, OH minus, pH, pOH, and then at the end, you need to tell whether it's acidic or basic based on what pH value you get. So for instance, if I gave you an H3O plus concentration of 2.76 times 10 to the minus first, you would need to find the OH minus by dividing into 1 times 10 to the minus 14th, because H3O plus times OH minus equals 1 times 10 to the minus 14th. So when you divide 1 times 10 to the minus 14th by 2.76 times 10 to the minus first, you'll get 3.63 times 10 to the minus 14th. Then to find the pH, you take minus the log of the H3O plus, so minus the log of 2.76 times 10 to the minus first, and you would get a very small pH of 0.56. And then for the pOH, you could either take minus the log of this 3.6 times 10 to the minus 14th, or you could subtract the pH from 14 to get the pOH, which would be 13.44. So the pH being 0.56 means that it is a very acidic solution. It has a low pH. Okay, so you're going to then do a bunch of problems just like this, where you're given one of the different things, and then you'll use the equations to find the other.